Think of your network like a chaotic, bustling metropolis. You've got millions of data packets zooming around like cars, and countless routing updates acting like dynamic GPS instructions just trying to make sense of all that traffic. Without rules, it's literal gridlock. So let's fix that. Welcome to today's Explainer, where we're going to explore the ultimate organizational solution to all this chaos, Junos policies. We're going to demystify exactly how Juniper devices establish order by tracking the incredible journey of both routing information and raw data packets as they travel through your device's architecture.
Here's our quick roadmap for this explainer. We'll start with the Junos Policy Framework, move into import and export policies, check out default routing policies, walk through route evaluation and actions, and then wrap the whole thing up by understanding firewall filters. All right, let's jump right in.
Part 1, the Junos Policy Framework. To truly master a router, you kind of have to realize it's constantly juggling two entirely parallel universes of traffic. And understanding the difference between the two main tools in your Junos toolbelt is absolutely crucial here. Think of the router as having a control plane and a data plane. Routing policies? Well, they live up in the control plane. They don't actually touch your Netflix stream or your web traffic directly. Instead, they control the routing information, the maps and the directions being shared between routing protocols and the routing tables. Firewall filters, on the other hand, are down in the trenches. They control the actual physical data packets that are transiting the router to some network destination, as well as local packets destined for the router itself. Moving on to Part 2, import and export policies. Now, there is an absolute golden rule of Junos routing that we need to establish right now. Seriously, if you remember nothing else from this explainer, remember this official note straight from the Junos documentation. The process of moving routes is always, and I mean always, described from the point of view of the routing table. People get import and export mixed up all the time because they try to think about it from the perspective of the protocol or maybe the neighbor router. Don't do that. Imagine you are the routing table. Routes that are imported come into you. Routes that are exported go out from you. Actually, I want you to picture your router's main routing table as the most exclusive VIP club in the entire network. An import policy is basically the bouncer at the front door. The routing protocols, like BGP or OSPF, they show up with this massive list of potential routes. The import policy looks them up and down and decides exactly what gets allowed into the routing table. An export policy, conversely, is like the club's PR agent. It looks at the active VIPs currently hanging out inside the club, the active routes inside the routing table, and decides which ones should be broadcasted and advertised out to the neighboring routers. So, import filters what gets in, export filters what gets advertised out. Make sense?
Section 3, default routing policies.
But what if you don't actually hire a bouncer or PR agent? What happens if you just turn the router on and plug it in? Well, every routing protocol comes with built-in default rules to ensure the network functions even before you start tweaking things. Let's break this down. For BGP, the default import policy accepts all received IPv4 and IPv6 routes from configured neighbors, and the default export policy sends out all active BGP routes. BGP is just inherently chatty. However, interior gateway protocols like OSPF and ISIS operate a bit differently. They inherently import everything into the routing table, sure, but their default export policy essentially rejects everything. And that's simply because OSPF and ISIS naturally share their link state databases within their areas anyway, so they just don't need a default export policy pushing routes out in the same way BGP does. This is your built-in safety net. Which brings us to Section 4, route evaluation and actions. So what exactly happens when a route steps up to your custom bouncer? Well, Junos evaluates policies in a really strict top-down systematic progression. When a route hits a policy, it's evaluated against the very first term. If the route matches the conditions of that specific term, the router immediately takes the specified action, like accept or reject, and boom, the evaluation stops right there. But if it doesn't match, it falls down to term 2. If it exhausts every single term in that policy without a single match, it drops down to the next policy in the chain. And if it makes it through every single term of every single configured policy without matching a thing, the router just shrugs and applies the protocol's default action that we just talked about. If you picture this logic visually, it's incredibly intuitive. A route enters at the top, it hits the first term, no match, it falls to the next one, and then the next one, almost like a pinball dropping through a machine. Eventually, it either hits an explicit accept or reject action within a term, which shoots it right out the side of the flow, or it plummets all the way down to the very bottom to meet the default action. It's a beautifully predictable, logical flow once you see it in action. And finally, Section 5, understanding firewall filters. We've spent our time so far hanging out up in the control plane, organizing the map. Now we're pivoting to the data plane.
While routing policies deal with abstract network destinations, firewall filters deal with the raw physical data packets hitting the router's interfaces. Here, we really have to distinguish between stateless and stateful filters. A stateless firewall filter, often called an ACL or access control list, has literally no memory. It evaluates every single packet in total isolation, looking only at static contents like the source IP, destination IP, or port number. A stateful firewall filter, however, is dynamic. It remembers past communications and tracks the ongoing connection state of the flow to make smarter control decisions. But it's worth noting that Junos leans heavily into highly efficient, protocol-independent stateless filters for rapid-fire packet processing.
So why do we even need these filters? Well, frankly, because the network can be a really hostile place. Firewall filters are your absolute frontline defense. They rate limit excessive traffic transiting your router so your interfaces don't get choked out. But even more importantly, they control local pockets destined for the router itself, protecting it from malicious external aggressions. They are specifically designed to neutralize ICMP floods, TCP connection request or SYN floods, and massive distributed denial of service or DDoS attacks.
Okay, here is a massive operational pro tip derived straight from the Junos framework. If you want to protect the router's brain, the routing engine, you don't actually need to try and configure complex local packet filters on every single physical interface. Instead, you apply a firewall filter directly to the device's loopback interface, which is designated as LO0 or LO6. Because all local traffic destined for the routing engine fundamentally terminates at the loopback anyway, placing your protective filter right there acts as the ultimate centralized shield for the router's entire control plane.
We've tracked the journey of routing information through the VIP club of import and export policies, and we've deployed firewall filters to shield the engine from raw data attacks. Which brings us to a final provocative thought to leave you with today. Take a look at your own network. If your routing table is a fortress, are your default Junos policies currently acting as an impenetrable wall, or are you unwittingly leaving the gates wide open? It might just be time to go audit those bouncers and PR agents. Thanks so much for joining me on this explainer. I highly encourage you to dive into your own device configs and see these concepts in action. Catch you next time.